Circuit rules, or Kirchhoff's circuit laws. In this video we're going to look at two different methods of helping you understand how a circuit works so you better understand what questions are asking you in an exam. Firstly, let's start with current rules. If you have a simple circuit like the one on the screen with a cell and two resistors, both of which are in parallel, any current coming out of the cell must equal the current coming back into the cell. Also, any current coming out of the cell and going into a junction splits. It doesn't have to split evenly. It can split in a number of ways depending on the resistance of the resistors, but the total current through both branches, represented there by I2 and I3, must equal, when added together, I1. You can't get more current in the two branches than is in the original wire coming out of the cell. Therefore, the following equation must always be true. I1 is equal to I2 plus I3, which is also equal to I4. Now let's look at a voltage rule. In a DC circuit, the voltage drop around any loop is zero. What this means is, if you have a potential difference from a cell of 1.5 volts across the terminals, 1.5 volts being at the positive terminal, 0 volts being at the negative terminal, you must have 1.5 volts dropped across the circuit in another place. So if we've got 1.5 volts coming out of the cell, we must have 1.5 volts across the resistor. So the V in, which is the PD across the cell, I1, which is the current through the resistor, and R1, which is the resistance of the resistor, if we put that into an equation, E in, which is the energy in, equals E out, well, V in must equal I1 times by R1. I times by R is voltage. So there is 1.5 volts in, there must be 1.5 volts across the resistor. Therefore, the voltage drop around any loop must be zero.